Hey everybody, Mr. Judson here. So we're still in chapter 1. We're still talking about functions, and we've got this new notation that you've probably seen before, but we just want to make sure we understand what it means. And this is actually fairly new as far as math goes. I don't ever remember seeing this written in the math books when I was in school. Okay, what I saw was this. This whole thing right here is equal to f of x plus g of x. But somewhere along the line, somebody decided we're going to write it a different way. I don't know, maybe they want their name in a book. Who knows? And so, and everybody kind of latched onto that. But whenever we say, well, what does that mean? Everybody says, well, it means this. And so I don't know why we don't just keep on writing it that way. I mean, I don't know. But that's what it means. We're just adding the two functions together. All right? If I do this, that just means f of x minus g of x. So when I see that, it just tells me we're subtracting the two functions, multiplying the two, f of x times g of x. And then, of course, dividing the two functions. So this would be f of x divided by g of x. And usually something like this will show up on the Central Washington test. Whatever f and g are, we just have to write it down and then do whatever we're supposed to do with it. That's what this is really saying. So let's take a look at a type of problem that we would have to do. Okay? All right, so this would be a typical problem. They would give us a function f of x and a function g of x, and then ask us to find f minus g of x, which really just means f of x minus g of x. So if I had to do that, here's the mistake that I see a lot of people make. They'll go, okay, x squared minus 2x plus 1 minus 2x minus 2. And then they'll go on and finish the problem. And that's not right. See, when they say subtract g of x, they mean subtract all of it. The only thing I did was subtract the first term, and I just left that the way it was. I need to write it like this. That negative sign has to distribute to each of those terms. So really this should be x squared minus 2x plus 1 minus 2x plus 2. And now we simplify it and add together our like terms. So if I did that, I would get x squared minus 4x plus 3. There it is. There's nothing else to do. It's not equal to anything. We're saying this is equal to that. But I see this happen a lot too. Don't do this. All of a sudden, people add to the problem and go, oh, okay, I've got to factor this and solve. Well, no, they didn't ask us to solve. They just asked us to figure out what f of x minus g of x is equal to. And there it is. Let's not turn this into something that it's not. All right? Let's get all that stuff out of there. I always worry that when I show that to people, they're kind of halfway listening, and in their head they go, oh, I'm supposed to set that equal to 0 and solve. No, don't do that. Okay? That's not what we're supposed to do. So what about this? Same two functions. F of x and g of x don't change. But this time I want you to find f times g of x. You guys go ahead and try it. Alright, so we now know that just means do f of x times g of x. This is what I'm talking about. If that really means that, why don't we just write this? It makes it so much clearer. I don't know. Nobody asked me. They don't care what I think. Alright, so I had, let's see, x squared minus 2x plus 1. And I want to multiply that times 2x minus 2. Let me just make sure I got everything right. Yeah, there's my original functions. So this isn't really a FOIL method because a FOIL method would only have two terms. But it's like a FOIL method. I'm going to take x squared times both of those. So I'll get 2x to the third minus 2x squared. And I'll take a negative 2x times both of those. So I'll get a negative 4x squared plus 4x. And I'll take 1 times both of those. So plus 2x minus 2. And then we just add up all the like terms. So 2x cubed, oh yeah. 2x cubed minus 6x squared plus 6x minus 2. There's my answer. That's all I got to do. What if I said, same two functions, this time I want you to find f divided by g of x. You guys go ahead and try it. All right, so we know this means f of x over g of x. So I want to divide those two functions. And the first one was x squared minus 2x plus 1. The other one was 2x minus 2. And so what I need to do is I need to factor these and see if maybe something will cancel. Remember, you cannot cancel things that are being added or subtracted to something else, or parts of things that are being added or subtracted to something else. So I cannot cancel this 2x with this 2x. It doesn't work. We've already shown that through a counterexample. So what I need to do is I need to factor the numerator. This is x times x. That can only be 1 times 1. And if those are both negative, I would get a negative 2x in the middle. Negative 1 times negative 1, that's positive, so that works. Factor a 2 out of here, and I've got x minus 1. And so now, because we're multiplying this set of parentheses, those can cancel. And my answer is x minus 1 over 2. There we go. All right, so that's one thing that they'll ask us to do today. All right, let's try another one. Here's two new functions. F of x equals x squared plus 5x, and g of x equals 4x minus 2. And they want us to find f times g of 2. You guys see if you can do that. So I feel like even if we don't really know what to do, we should be able to figure this out. Right? This thing right here means the same thing as f of 2 times g of 2. Well, what does f of 2 mean? It means plug a 2 in and see what you get. What does g of 2 mean? Plug a 2 in, see what you get. And when you're done, just multiply the two answers. So this is going to equal, if I plug in a 2, I'm going to get 4 plus 10. Over here, I'm going to have 8 minus 2. And so that's really 14 times 6, which is 84. Remember, an easy way to do that is you just do 6 times 10, that's 60. 6 times 4, that's 24. And usually those are pretty easy numbers to add together. 60 plus 24, 84. Okay, we don't need a calculator for that. That's easy. What about this? Same two functions. This time I want f over g of 3. You guys try it. So this would be f of 3 divided by g of 3. And so if I go back and plug a 3 into this equation right here, I get 3 squared, that's 9, plus 15. I never write from this side. And then I plug a 3 in here and I get 12 minus 2. This is going to be 24 over 10. I'm always amazed when I get asked this question in a class like pre-calculus. Do we have to reduce? Yeah, we have to reduce. Yeah. So if I divide both of those by 2, I'm going to get 12/5. And it'll stop right there. We don't need to change that to 2 2/5. We don't have to do that. If you do, it's fine. No big deal. If you write your answer as, what is that, 2 2/5 would be 2.4. You can do that. Same number, I don't care. I'm just going to reduce it and stop right there at the fraction because, usually when we say exact answers, we usually mean fractions or square roots. And so I'm just going to stick with that. All right, so this is called a composition of functions. And again, I don't ever remember things being written this way when I was a kid in high school. What I remember is this, f of g of x. That's the way we wrote it. And what's funny is in our books it goes, oh, well this right here means that. And so again it's like, oh, well if it means that, let's just write that. But we don't. We write it this way. So sometimes people call this the fog function. It's not an O, it's a little tiny circle, and it's not to be confused with a multiplication sign either. It means something different. It means we're going to take the function g and plug it back into the function f. Just like this says, if I said f of 2, I would take a 2 and plug it back into this function. Well, now we're saying f of g of x, so whatever g of x is, that's what's getting plugged into this function. Okay? And same thing here, we're taking f and plugging it back into g. So this would be g of f of x. Whatever that function is, plug it back into the x variable that we'd have here with g. Let's do an example of this. Let's say f of x equals x squared minus 4. We'll put an x in there. Okay. And g of x equals x plus 2. So what would f of g of x be equal to? Well, we're taking whatever's listed second and plugging it back into this. That means we're going to take this function and plug it back into this one. All right, so I'm plugging this function back into both of these spots here. Kind of like in our difference quotient, right? We had x plus h or x plus delta x, we're plugging that back in. Now we're just plugging something different in. So this is going to be x plus 2 squared minus 4 times x plus 2. And so now I just have to multiply it out and see what I get. So I'll square the first term, multiply the 2 and double it, square the last term. Here I'll distribute a negative 4, so I'll be a negative 4x minus 8. And then what I get is x squared, 4x minus 4x, and then 4 minus 8, that's negative 4. There's my answer. That's what this thing is equal to. All right? Same two functions. Let me have you guys try this. I want you to find g of f of 4. You guys go ahead and try it. All right, so that means the same thing as g of f of 4. So what that means is I've got to take 4 and plug it back into this function first, and then whatever that answer is, it gets plugged into g. All right? So I'm going to do f of 4 first. So f of 4 equals, we had x squared minus 4x, so that would be 16 minus 16. That's 0. So now we're saying this is equal to g of, answer to that was 0. So now I got to plug a 0 into the function g. And so if I go back and do that, if I plug a 0 in right there, I just get 0 plus 2. There's my answer. Let's try another. I've got f of x equals the square root of x squared plus 2, and g of x equals x minus 5. And what we want to do is we want to find f of g of 10. You guys try it. Alright, so that means I'm trying to find f of g of 10. So I need to plug the number 10 back into the function g first. And so g of 10 is just going to be 10 minus 5, g equals 5. So that means this becomes f of 5. Whatever that answer was, that's now what's getting plugged into this function. So plug in a 5 right there, and we've got the square root of 25 plus 2, which is the square root of 27. You could hit the buttons on the calculator if you want, it's okay. But if the directions said to give an exact answer, then we have to simplify this. So I would just get in the habit of doing that. Anybody can hit calculator buttons, right? Always make yourself do what's more complicated, because that way when it comes along, it's not that big of a deal. So this would be 9 times 3. Square root of 9 is 3. And so I get 3 root 3. There's my answer. All right, let me have you guys try one more problem. This one's a little different. I've got f of x equals 3x minus 2x squared, and I want for you to find f of 2. You guys go ahead and try that. Well, let's see, that must mean f of 2. F of 2. So that means I need to take a 2 and plug it back into this function, see what the answer is, and then take that answer and plug it back into that function. So f of 2 is going to equal 6 minus 2 times 4, that'd be minus 8, which is a negative 2. So this is equal to f of, this right here gave me an answer of negative 2. So now I'm taking that number and plugging it back in there. So 3 times a negative 2, that's going to be a negative 6. Negative 2 squared, that's 4. Times a negative 2, that's a negative 8. And so my answer here is a negative 14. All right? Just take a number and plug it into the function, and whatever that answer is, you plug it back into the same function. All right. All right, so here's our assignment. This is assignment number 7 for Monday, Tuesday, depending on which class you're in. We're on page 89. We're going to do 5, 7, 11, 13 to 19. We'll do just the odds in that group. And 35, 37, 41, 43 to 46, we're only going to do part A. There's like a part A and a part B. Just do part A, okay? All right, there it is. You guys have a good day. Stay safe. I'll see you via video on Wednesday. All right, take care.